Okay, today we're going to be talking about the area and circumference of a circle, and then the arc length and sector area of a section of a circle. So we've got two diagrams here. And on these diagrams, I have a radius marked because that's going to help you in the circumference formula. And then in the second diagram, I have a diameter. And so the diameter isn't a part of the formula. However, the diameter is actually two of the radiuses, or the radii. So this part right here is the radius. So if we had the diameter, we would just cut it in half in order to get the area. Let me first talk about what a circumference is. So a circumference is the distance around a circle. Okay, and you're going to see me using this formula of 2 pi r. I'm doing that because I like to use the radius in both the circumference and the area. This is another formula, pi times diameter, but if I'm going to have you memorize one formula, this is the one that I would prefer. Okay, so the circumference is the distance all the way around a circle. The area is the amount of space inside the circle. So this is the area. Right here. All this space inside. Okay, and that formula is pi times r squared. Okay, so let's use those two formulas to find the circumference and the area of these two examples. So I need the radius. So on number one, that's given that the radius is 8 centimeters. And then I'm going to use both of my formulas. So my circumference is 2 pi times that radius. So for this example, 2 pi times 8. Okay, so what I'm going to have you do is only type in the 2 times 8 in your calculator, which is a 16, and then leave the pi next to that as your answer. So the exact value of your circumference is 16 pi, and then we use our units, which is circumference, or sorry, which is centimeters. And then let's do the area. Area is pi r squared. So pi times 8 squared. 8 squared is 8 times 8. So that would be 64 pi. And then we need to use our centimeters. And when we're doing area, it means our units are squared. So this would be 64 pi centimeters squared. Okay, let's do the same thing over on number 2. So this time we're given the diameter. So if the diameter is 8, halfway would be our radius, which is 4. So our circumference, again, 2 pi r. So 2 pi times 4. Again, just multiply the numbers together and leave the pi next to it. And again, we have centimeters. So our exact circumference is the distance around, it's like a perimeter of a circle, is 8 pi centimeters. And then our area that's covering the entire circle is pi r squared. So pi times 4 squared would be 64 pi. Don't forget your units. Squared because it's area. Oops, actually, I'm sorry. That is 16, not 64. So this is 16 pi centimeters squared. Okay, so this next part down here is having us actually type these into our calculator and then round them. So I would like you to type into your calculator right now 16 pi Okay, maybe pause the video and then come back after you have typed that into your calculator so you can see what the decimal approximation is. If you round that to the nearest tenth, which is 1 decimal place, that would be 50.3 centimeters. If you round it to the nearest hundredth, which is 2 decimal places, it would be 50.27 centimeters. If you type in 64 pi into your calculator, go ahead and pause the video and do that. Okay, so if you type in 64 pi and you round to 1 decimal place, it'll be 201.1 centimeters squared, and this will be 201.06 centimeters squared, 2 decimal places. Okay, so pause the video now and do the circumference and area, both of those rounded to the nearest tenth and to the nearest hundredth, and then come back to the video after you have done both of those to check your work. All right, so check your answers. How did you do? Hopefully you did well. Let's move down to the next part of our notes. So second half of our notes deals with parts of a circle instead of the entire circle. So a sector of a circle is a section here, as you can see shaded. So the area of that sector, you can see it's shaded in blue, just means you have your area formula, but then what part of the circle did we take? Because we don't have the entire area. We only have this little piece. So we need to find out what that angle is for that arc. So that arc over 360 will tell us what fraction of the circle we have, and then we can use the area formula. Okay, so that pi r squared comes from the area formula above. So this is in blue, so I will shade that in blue, and that's talking about this sector. Okay, you can think about this as like a piece of pizza. Okay, so this is the entire piece of pizza. The arc length means what part of the circumference do you have? The best way to think about this is that you're just thinking about the part on the outside, or you're just thinking about the crust on a piece of pizza. So remember, all the way around is a circumference. The formula we used was 2 pi r, but we don't have all the way around. We only have a piece of it. So if we take this part right here, that angle measure over 360 will tell us what fraction of the circumference that we have. So basically these two formulas involve the area formula from above and the circumference formula from above, but we don't have the whole circle, we just have part of the circle. So I'll show you what I mean on the back when we go through an example. So arc length uses the letter L to represent its formula, and then the sector of a circle, the area there, is the A. Okay, so we need the radius in order to find this, and we need to know what that angle or that arc measure is for each of the sectors of the circle. Okay, so we've got that here. Here is my arc, and then my radius is given as 6. Okay, so we're going to use both of the formulas, substituting in those values. So we'll do the arc length first. So the arc length would be taking that arc over 360 and multiplying by 2 pi r. So the arc that I have is 60 degrees over 360 times 2 pi, and then my radius is 6. So now you're going to separate this in 2 different ways, okay? So I don't want you to type all of this into your calculator. What I would want you to do is to type in 60 over 360 as a fraction, and it'll tell you what part of the circle you have. How much do you have? So 60 over 360 is 1/6. So what is shaded is 1/6 of the circle. Now if you take the 2 times the 6, that will be a 12 with the pi. So we have 1/6 of 12 pi. So 1/6 of 12, or 12 divided by 6, would give you 2 pi. So the exact value of my arc length would be 2 pi and then centimeters. If you did type this into your calculator, if you did type in the pi, so if you had typed in 2 times pi, you would get to the nearest hundredth, or 2 decimal places, 6.28 centimeters. So I'm actually okay with either answer. If you leave it in pi form or if you do the decimal form, either one of these will be okay on all the homeworks that I give you. Okay? All right, let's do the sector area. So the sector area is taking that same arc over 360, and this time you're multiplying by by pi r squared. Okay, so 60 over 360 again, and then pi, my radius is 6, and I'm squaring it. So you don't need to enter this into your calculator again. 60 over 360, we already found out was 1/6. And then 6 squared is 36 pi. So we've got 1/6 times 36, or 36 divided by 6, gives us 6 pi for our sector area. So 6 pi, our units of centimeters, because it's area, square that. Okay, and then if we type that into our calculator and round to the nearest hundredth, second decimal place, that would be 18.85 centimeters squared. Okay, I want you to pause the video right now, and I want you to try and do that exact same thing right now for example number 4. And when you unpause the video, I'll have all the work there for you to check. Okay, so pause your video and work through all of example number 4 on your own. Did you really pause the video and try it by yourself? Because I'm wondering if maybe you're stumped because your arc is not given for the part that's shaded. So remember that all the way around a circle is 360 degrees. So if the part that is not shaded is 240, you'll do 360 minus 240 to get the arc of the shaded piece. So that'd be 120 degrees. So this is the part that you need right here for your arc in each of your formulas. So go ahead and pause the video again and try that. Okay, so these answers don't look the same as example number 3 because the fraction didn't work out nicely with what we had left in front of the pi. So we had our arc over 360, so 120 over 360, which reduced to a 1/3. And then we had 2 times 8, which is a 16 times pi. And then 1/3 of 16 is like 16 divided by 3. Well, that didn't divide nicely. So we left it alone because it didn't reduce. Same thing happens when we do the sector area. 1/3 of 64, or 64 divided by 3, isn't a whole number. So we left it as 64 over 3. You might notice that when I filled in these exact values into my table, I put pi up with the 16. You can write it this way, or you can write it as the fraction and then write the pi next to it. If you type this into your calculator to get yourself a decimal approximation, be careful. Make sure you do the 16 times the pi, then hit enter, and then divide by 3. What you should get is 16.76 inches. So make sure that you type this in and you check this word. Okay? If you're not getting this answer, then put this 16 pi in parentheses before you divide. Same thing with the sector area. 64 times pi, hit enter, then divide by 3, and what you should get is 67.02 inches squared. If you're not getting this answer, use parentheses before you. Okay, then last question we're going to do together. We're not going to do example number 6. We're going to have to figure out what this arc measure is with the information that's labeled on our diagram. So what I see is a right angle here, which means that this is 90 degrees. So remembering that all the way around the circle would be 360, if we did 360 minus 90, that would be 270 degrees for this arc. And then my radius is given here as 16 yards. So my arc length, which would be like the crust of the pizza, just to the outside perimeter kind of, would be 270 over 360 times 2 pi r is 16. In your calculator, if you do 270 over 360, what you should get is 3/4. And then 2 times 16 is 32 pi. Now, a couple different ways that you can do this. You can do 3/4 in parentheses and then multiply by 32, or you can do 3 times 32 and divide by 4. No matter which way you choose to do this, you should end up with an answer of 24 pi. So the arc length here is 24 pi, and then my units are yards. Okay, so I hope that you're actually checking these in your calculator, because that's how you'll be doing your homework. You won't have my answers here to check. So make sure that you're entering this into your calculator and trying to get the same answer as I have. For our arc length, or for our sector area, we're going to do that same angle of 270 over 360. And then this is times pi r squared. So this fraction reduces in the same way as it did in the arc length formula, as 3/4. And then 16 times 16 is 256 pi. So 3/4 times 256 should get you 192. So the sector area is 192 pi yards squared. If you type this all into your calculator at one time, even if you typed all of this into your calculator at one time and you had your fraction in parentheses there, you should get an answer to decimal places of 75.40 yards. And if you typed in 192 pi, you'd get 603.18 yards squared. Okay, so just one last thing I want to let you know. I'm going to take either answer here. I'll take either the exact answer or I'll take the nearest 100. If you typed all of this in at one time and you were able to get this answer, I'm okay with that. If you typed all of this into your calculator at one time and got this answer, I'm okay with that too. A trick to doing that though would probably be to put the fraction in parentheses before you hit multiply. Put the fraction in parentheses before you hit multiply. That might make doing all of this easier if you could do it from this part that I highlighted in yellow and get this answer. So maybe that's another thing that you can check before you start going to your homework to see if you could get this entire thing entered into your calculator to get the highlighted decimal. Okay, so this is the homework that you're going to be working on tonight and tomorrow. If you have any questions, just reach out to me. Thanks. Have a great day.